Anything else. Today we're going to deal with sex, evolutionary, hormonal, and neural bases. And that is chapter 12 in your textbook. Always an interesting chapter. Yay, balloons. First thing we're going to talk about are the 4 stages of reproductive behavior. If we talk about them, we can refer back to them when we're actually talking about everything else. Stage 1 is sexual attraction. In most species, sexual attraction cannot take place until the female is ready to reproduce. That's most species, but that doesn't include humans. This can be judged by whether males approach her and how rapidly they approach her. If you're talking about animal husbandry and you're talking about cows and bulls, this is how you know that the cow is ready to reproduce, and then the bull will approach her, and if she's not ready, then he won't mount her. The female will show attraction to the male by whether she allows him to approach or not. Normally, females just stay away from the males. The males will only approach the females if they are receptive. In many mammalian species, a female will demonstrate her approachability through swelling in the vaginal area that is a different color and an odor regulated by a surge in estrogen. In most species, intercourse is not possible without full female cooperation. Stage 2 is the appetitive behavior that establishes, maintains, or promotes sexual behavior. When a female is displaying this behavior, she may approach a male, she may stay close to the male, she may show alternating approach and retreat behavior. She may move in a specific manner that will result in the male mounting the female. This is known as proceptive behavior, this putting herself in a certain position so that he can mount her. Male appetitive behavior may consist of staying near and sniffing the female, and that is stage 2 for both the male and the female. Stage 3 is copulation or coitus. Copulation begins when the male puts his penis in the female's vagina, an act known as intromission. Through rhythmic movements, the male will then squirt sperm-filled semen into the female's reproductive tract. After copulation, the two will go through a period when they will not be able to re-engage in intercourse, and this is known as the refractory phase. However, a male presented with another female may show a shorter refractory phase. This is called the Coolidge Effect. When a female is ready to copulate, she will be sexually receptive. The Coolidge Effect was named after President Calvin Coolidge, or Silent Cal as they called him. They were visiting a farm in Iowa. He's actually from Kansas, I think. Anyway, Coolidge, they were visiting a farm, and they were showing them. It was spring, and they were impregnating some of the females on the farm, and Mrs. Coolidge was watching a bull mount a heifer, and or a cow. I guess it was a cow, probably not a heifer. Anyway, she was watching, and she was watching, and she said, "Cal, look at that." And Cal was over by the chickens, and he said, "Oh yeah, well look at this." And here the rooster was mounting one chicken after the other. So the idea was that she was talking about the prodigiousness of a bull reproducing with a cow, but he was talking about the frequency that a rooster got to breed with chickens, and now it's known as the Coolidge Effect. The fact that if you have different females, then you're more likely to be able to experience both females very quickly. But if it's the same female, then you're less likely to be able to do that. Stage 4 is the post-copulatory behavior. This is different in most species. The males of all mammals but primates achieve and maintain their erections with a bone in their penis called an os penis. Sometimes, as with dogs, the male is unable to remove themselves from the copulatory position for minutes after ejaculation, so they have to stay mounted on the female. The whole purpose of copulation is the joining of the male and female gametes, the ova in the female and the sperm in the male. If the two join, the ova will become fertilized and the union will become a zygote. While all mammals, birds, and most reptiles fertilize inside the body, internal fertilization, fish and frogs fertilize outside the body, and this is known as external fertilization. So there you go. Males, birds, and most reptiles have internal fertilization, but frogs and fish have external fertilization. If the species lays eggs outside the body, as birds and reptiles do, it is called oviparity, or egg birth. If the species allows the zygote to develop in the female's body, it is referred to as viviparity, or live birth. For most creatures, there is only one sexual position they can be in for copulation to be possible. Since most mammals walk on all fours and have a tail, reproduction can only take place if the female raises her rump and moves her tail to the side. This will usually straighten her vagina adequately for penetration to occur, and this is known as lordosis, and this is a cat in lordosis. She's in a position where she has straightened out her vagina, and it's possible for the male to penetrate and reproduce with her. For frogs to mate successfully, the male must mount the female. There is no penetration, but as the female emits her unfertilized eggs, the male must release his semen. If this does not take place in or over water, reproduction will not take place. This position is known as amplexus. And there you go. That's what amplexus looks like. And these are the eggs, and they have been washed or splashed with the male's semen. While sexual response is extremely complex, the female anatomy for intercourse is relatively simple. Two folds of skin cover and protect the vaginal opening, and these are known as the labia. Labia just merely means lips, so the lips on your face are labia, and the female labia in her reproductive area are also known as labia. The female erectile tissue is the clitoris above the vaginal opening, and it's sometimes difficult to locate the clitoris, but it's her erectile tissue that's right above the vaginal opening. Since male delivery of the gamete requires penetration, the male system is more complex than that of the female. Erection takes place due to an engorgement of blood. Semen is produced in the testes and stored in the epididymis. During ejaculation, the sperm travel up the vas deferens past the seminal vesicle, prostate gland, and Cowper's gland, where it picks up a viscous alkaline fluid called semen. And it gets something from all of these different vesicles. Normally, the male is not erect because cells in the glands of the penis, the paragigantocellular nucleus, the PGN, send serotonergic fibers down the spinal cord that inhibit erection. During sexual excitation, the forebrain inhibits the PGN and allows the penis to become erect. Selective serotonin reuptake inhibitors increase serotonin in the brain and may not allow the inhibition of the PGN. In other words, the individual will be unable to get an erection. While there is no normal or typical when it comes to sexual response, too many social and psychological factors involved, women achieve vaginal lubrication during the excitement phase. Males have a smaller amount of lubricating exudate during erection to ease penetration. Males typically have one basic pattern of response, but they do pass through a refractory phase after orgasm when erection is difficult. Females, however, rarely have a refractory phase, thus multiple orgasm is possible, but have three typical patterns of response. And these are the three typical responses. As you can see, A is there's a plateau and then an orgasm, and then a resolution. B is with no orgasm, and then they get excited. They never quite reach orgasm, and then they have a resolution phase. And then C is a fairly rapid excitation phase that leads to a prolonged orgasm, and then refraction, or resolution, I'm sorry. In many situations in nature, the males and females of the species are very much different in size as well as structure. In most vertebrates, the male is larger because he must battle other males for the right to reproduce. Another definition of sexual dimorphism is that the male gamete is abundant, small, and cheap, while the female gamete is large, rare, and expensive. And that is sexual dimorphism. Because of the low cost of producing sperm, males can easily gather enough nutrients and energy to impregnate millions of women. Probably not, but they potentially could. Whether males are selective or not, the odds are that they will have some offspring that survive. Females, on the other hand, have to be more selective. Females that carefully nurture their costly eggs are more likely to have offspring that survive to be the next generation. Thus, females must mate carefully. Males that carry many beneficial genes are more likely to provide the female's offspring with favorable genes. But how does a woman do this? The female must closely observe the appearance and behavior of the male. A vigorous, healthy male is more likely to carry good genes than an unhealthy one. Thus, courtship is a period when the female assesses the genetic makeup of a male to judge the suitability as a mate. And this, of course, is J-Lo. And this is J-Lo's many husbands. He was a dancer. He was an actor. He's a singer. And actually, I think they reproduced. They actually had children. Now this is the man she's married to. She's married to Ben Affleck. There's J-Lo. So she has been fairly selective in her life. We'll assume. Oh, there she is with Alex Rodriguez, who was her boyfriend before she married Ben Affleck. She dated Ben Affleck before, and that's why I had the picture in here. Just so happens she married a guy that she used to date. Anyway, she never married Alex Rodriguez. I guess I can take that one out. Okay. There are 4 mating strategies that are used in the animal kingdom to ensure offspring survival. The first is promiscuity. Females will mate with more than one male, or as many as they can, in any mating season. This will ensure that the male with the most attributes going for him is more likely to be the sire. Polygamy, also known as polygamy, is where the male maintains a harem of females that he will exclusively mate with. Most ungulates mate in this fashion, as do gorillas and elephant seals. This is also practiced among humans in many parts of the world, where a husband will have more than one wife. Polyandry is rarer than polygamy, but is still known to occur. In polyandry, one woman mates with more than one man, but those men can only mate with a single female. This is practiced in Tibet, and very often what will happen is brothers will marry a select wife, and then they will both mate with that female. Monogamy is the most prevalent mating method among humans. In monogamy, a pair will form a mating pair where exclusive access is maintained between both the male and the female. This seems to be the best manner in which a woman can gain resources from the male when he must provide for his children to ensure that they will survive. Sexual selection takes place when the female selects the male that they wish to mate with. Sexual selection among birds is the most garish of all creatures. In order to attract a female, a male will weigh themselves down with impossible structures such as a peacock's tail, and that's how he attracts females. Some species participate in intricate mating rituals during courting that are not only garish, but call attention to themselves from potential predators. Almost all male birds have intricate songs that they sing in the spring during mating to attract a female. In some species, courting is extensive. Among large cats, only vigorous exercise over several days will bring the female to ovulation. Wadabi, males of Niger, trying to charm females with eye movements and makeup. And these are the Wadabi. I'm going to show you a film about the Wadabi right now.
The men sing and sway to gain attention. They flutter their cheeks, cross and roll their eyes and grin. Whites of eyes and teeth are considered particularly beautiful. A man who can roll one eye and grin at the same time is considered especially desirable. The Garawal bring two different Wadobi lineages together, allowing each clan to propagate. Parents arrange first marriages at birth, and only cousins of the same lineage may marry. After that, they may seek a partner from another lineage. Mo Reube works his charm on Mary Moore. It appears to be working. The young wife decides she will allow him to steal her from her husband.
I'm with a husband that I don't like, and when I saw More Ube, he was the best. He was better than any of the others, so that's why I agreed to marry him and go home with him.
A Wadabi woman can't be taken against her will, though what More Ube is about to do in the name of love can still have fatal consequences.
If they get caught en route, then the husband has the right to require her to come back. If she disagrees, doesn't want to go back, there can often be a fight, and it can be to the death.
More Ube must plan carefully to steal his new wife and not lose his life.
I go to see the girl, and I explain to her that I want her. And if she says that she wants me, then I look for her husband. If he doesn't see me, I sneak up on the ground. If she accepts, I say come and look around. If I hear somebody coming, I hide.
The moment of truth arrives. Under cover of darkness, More Ube heads toward Mariam Moore's camp, not knowing if he will be greeted by her husband's sword.
The ideal is if she makes it all the way to the new husband's house without being caught, and then she has the full right to stay.
The new day will reveal whether More Ube's dangerous gamble pays off. The Wadabi are nomadic. They travel the desert and its fringes in extended family groups. This Garawal is an opportunity to mix between those groups and widen the gene pool for each clan. The men can have many wives, but when a Wadabi woman becomes pregnant, she will return to her mother's home, where she will remain for 3 or 4 years. During that time, she must not see or speak with her husband, and he is free to gather more wives. It is early morning, the day after the Garawal. More Ube returns from his quest. Last night, the game of love went his way. When he snuck into Mariam Moore's camp, fate or good fortune were on his side. Her husband was not there.
Ta-da! Okay, love conquers all. There we go. Good news. Okay, these were the Maasai. hire herdsmen, and what they're doing is, this is how they look for lions. They bounce up and down above their cattle. And of course, the higher you can bounce, the more likely that you'll be able to keep the lions away from your goats and your cattle. So they have a competition, and women watch them. The hat actually means that he has killed a lion. So, there you go. Mating practices. There's the Wadabi women, and these are the Maasai women. I just wanted you to see what they look like. Wait a second. There we go. Okay, these are the Wadabi women, and these are the Maasai women. And those are the Wadabi men. The Wadabis consider themselves the most attractive people in the world. So, there you go. Sexual differentiation takes place among most humans while still in the womb. The sperm either carries a male or female chromosome. All ova are female. Thus, males are the heterogametic sex because of the two different chromosomes, X or Y, while females are homogametic. They only have X. So it's the males that will determine the sex of the child. The sperm will consider the sex of the child. Very early in the development, the gonads are not differentiated, and this is when they are referred to as indifferent gonads. In mammals, the Y chromosome contains an SRY gene that is responsible for the development of the testes. If the individual has a Y chromosome, the cells of the indifferent gonads begin making SRY protein. The SRY protein causes the core of the cells to proliferate over the outer layer of the cells, and the gonad becomes a testis. And that's what males are supposed to look like. Just kidding. That's what females are supposed to look like. Just kidding. That's only 25 pounds. It's not that big. If the individual has no Y chromosome, no SRY protein is produced, and the indifferent gonads form with the outer layer dominant and the inner core is inhibited. As the fetus begins to form, they develop two ducts that connect the indifferent gonads to the cell wall, the Wolffian duct and the Mullerian duct. If bathed in testosterone from the testes, the Wolffian duct will develop. If not, the Mullerian duct will develop. If SRY protein is released by the Y chromosome, the gonads become testes and bathe the area in testosterone. The Wolffian duct develops into the vas deferens epididymis, and the seminal vesicle, the Mullerian duct, disappears. The genital tubercle becomes a penis, and the genital fold becomes a scrotum. If both the chromosomes are X's, the gonads become ovaries. The Mullerian duct develops into the fallopian tubes, uterus, and the inner vagina, and the Wolffian duct disappears. The genital tubercle becomes a clitoris, and the genital fold becomes the labia majora and labia minora. Testosterone from the testes releases a hormone called anti-Mullerian hormone that shrinks the Mullerian duct. It causes tissue around the urethra to form the prostate gland. It causes epithelial tissue around the urethra to form a scrotum and penis. The epithelial cells have 5-alpha reductase, which converts alpha reductase, which converts testosterone to dihydrotestosterone, which allows masculinization. If the sperm or the ova do not have a sex chromosome, the individual will have only one X chromosome. This individual has what is known as Turner syndrome and will be a female, have a short stature, and not develop secondary sexual characteristics. And that's what happened with this individual. I'm trying to think. Hunt is her last name. I can't think of her first name. Anyway, she has Turner syndrome, and that's why she's so short. And this is an individual with Turner syndrome, and this is her sister. And this is an individual with Turner syndrome, and this is her sister. As you can see, only one X chromosome. And that makes them a biological female, but they don't develop any secondary sexual characteristics. If the female fetus is exposed to androgens in the uterus, she might develop congenital adrenal hyperplasia. The overactive adrenal glands will produce more androgen and cause genitalia that appears as either an undersized penis or an oversized clitoris. Since the androgen receptor is on the X chromosome, if an XY chromosome or individual has a defective androgen receptor, they will not be sensitive to the androgenetic hormones. These individuals are referred to as androgen insensitive. These individuals will develop external female genitalia and develop all secondary female sexual characteristics except for menarche and have a shallow vagina. And these are cases of androgen insensitivity. There are a group of males in the Dominican Republic whose 5-alpha reductase converts testosterone to dihydrotestosterone, which allows the penis and the scrotum to form, is mutated. The 5-alpha reductase is mutated. Despite the fact that the individual has an XY chromosomal structure, the lack of 5-alpha reductase does not form a penis. The area that looks like a vagina has no vaginal opening. Because they do have testes with puberty, their bodies are bathed in testosterone and their penis develops. Their hips narrow and their build turns obviously masculine. These individuals who were raised and acted like females suddenly begin looking and acting like males. Most will become males. This is a male who is gravidoces. And here is somebody who is gravidoces as well. And at 19 years, he starts developing a penis. Before, he looked like a female. And there's an individual who decided to remain a female, but he has a penis. And there's another individual who decided to become a female or to stay a female, or she started taking male hormones, and as you can see, she is different. And there's somebody who was raised as a female, but when they reached puberty, they became this. Whereas before, they were considered a female. And that is the end of the chapter. So there you go. We'll talk to you next week.